Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Business Intelligence and Data Science meeting. We have with us the one and only Eugene Meidinger, because he has killed all the other Eugene Meidingers in the multiverse. So, because of that, it is our honor to host him tonight. And with that, I'm going to hand it right over to Eugene to take over from here. So, take it away, Eugene.
Yeah, so give me 1 second there, and then, okay, so let me go ahead and share my screen.
You know what? If I were professional, I would vamp while you were doing this. So maybe I'll do a little bit of vamping while it comes up.
Yeah,
There we go.
no,
Just enough
it's too
vamping.
late. Well done. Yeah, saved me. Okay, so this presentation is kind of high level and trying to just make it so that some of the stuff with large language models is a little bit more approachable. So just some quick context. My name is Eugene Meidinger, and I primarily work with Microsoft Power BI. That's what I get paid to do. But Microsoft, as you're probably well aware, has made a pretty large investment in OpenAI. And there's co-pilots everywhere. There's co-pilots to help you put on your shoes, all that kind of stuff. I joke. And so I think it's important to start to understand how this stuff works and at least a little bit of the math behind it. The goal for by the end of tonight is for you to have just an intuition for how some of these different pieces work and maybe provide you with some videos to check out or some resources from there. At any point, please feel free to ask questions. If I have an idea, I'll answer them. If I don't, and it involves actual math, I'll hand it off to Kevin and he'll be able to give you a real answer because he's a data scientist and I just play one on TV. So with that out of the way, oh, did my screen share? Oh no, that was something else. Okay, so the agenda is we're going to talk a little bit about why does it matter. We're going to talk a little bit about some of the math involved, and I'll show you some resources if you want to try and start from scratch yourself and to try some of this stuff. Unfortunately, I have been wrestling all day with getting PyTorch running on my Windows machine, so I wasn't able to get the demos working, but I can at least point you in the direction of some resources. So why does it matter? Why do we need to start learning about this stuff and thinking about this stuff? And the way that I describe ChatGPT is as a drunken but very energetic intern. And we're going to see a lot more of it. And so it's really important to understand its capabilities or lack thereof. So I asked ChatGPT to make this picture. It would not let me make a picture of it drunk. So this is a picture of it dizzy and drinking soda. There's actually some interesting exercises out there where you try to jailbreak a GPT to kind of get around the guardrails, right? They have to put these things in to make sure people maybe aren't doing certain things that they shouldn't. But when I say that ChatGPT is a drunken robot intern, that means a couple different things that are very important for understanding what's going on. So the most important thing is that ChatGPT is often wrong, and particularly it's confidently so. I have played around with it quite a bit, and let me, as an example, I might ask it, hey, explain this reference, or try to, based on some sort of like, make in the style of Dungeons and Dragons, make an anagram for something or whatever. And when they've explicitly programmed in guardrails to put little disclaimers and that sort of thing, it'll put those. But a lot of the times it'll be like, this is the answer, or this is whatever. And an interesting test that you can do, and we can actually probably do it right now. I've been having some issues with ChatGPT in terms of the live portion, so I'll probably have to reload the page. But let's go to 3.5 real quick. there's something called the Apple test, right? And so what you do is you say, give me 10 sentences ending in the word apple. ChatGPT 4 can pass this. 3.5, we'll see. I think it can. A lot of other large language models, a lot of worse ones or one that haven't been trained as well, do not pass this test. Like I said, I've been having some sort of weird thing where it doesn't, I don't know if it doesn't like Edge or what, but and so we can see here that it passed it for 2, 3, 4, 5, right? So 50% of the time, what seems like a really simple task, ChatGPT 3.5 has failed. And this is really important to understand. We're going to talk about this when we start talking about the structure of it. But ChatGPT has no inherent understanding of the world whatsoever. Later on, I refer to it as a fancy autocomplete. And so it's not too surprising that it might be bad at some of these weird sort of tasks. Another example is I've done stuff where I ask it to like write a paragraph without the letter E. And it's probably going to write it about apples because it's all of this previous text is being sent in as part of the context window, if that makes sense. So again, depending on the platform, it'll kind of animate. It doesn't seem to like me on Edge, but let's see if I give enough time. And so we can see immediately that it has failed. So foliage, got a lot of, it did all right on some of these. Echoing
The
forest.
fifth word.
Yeah.
Or sorry, sixth
Yeah.
word.
Oh, that's right. You're right. Grove. So it can't do this, right? Now let's be fair. We have Chat GPT 4 if you pay for that. So let's give it the Apple test. Write 10 sentences ending in Apple. It would help if I could pass the writing test.
It might make a difference if you say please.
I could. We could test that. Please.
Uh-oh, it may actually end in apple, please.
That would be funny. It's usually pretty smart enough to tell. Apple selection process. So as you can kind of see here, ChatGPT 4 got 9 out of 10. Right? It did not succeed here at number 7, but it's better and more effective, right? And again, if I ask it, write a paragraph without the letter E, please. I'll give it a couple seconds to run, but in my experience, it's going to fail at this task. And some of you watching at home may think, well, thankfully my job doesn't depend on, I think the term is lipograms, lipogram book, which is a text that's missing a portion of text. But if you're ever interested, there's a novel called Gadsby that I want to read. Doesn't have the letter E. There's also another one called Elemento that actually sounds a little bit more interesting. But thankfully, my job doesn't involve that, right? But again, let's see. No, illuminates. Fourth word did worse. The point being is that it has no comprehension, no understanding of the world. It is a statistical machine taking in a large corpus of text and then applying some refinement through something called gradient descent that we'll talk about. And that's it. So going back to the presentation, it's confidently wrong. But the other thing that's important is that often it doesn't matter, right? There's a joking law called Sturgeon's law because I think I'm going to get the quote wrong, but basically some sci-fi author was complaining about the quality of sci-fi, and someone said this is crap, and I think Sturgeon or someone replied 90% of everything's crap, right? And that's Sturgeon's laws. 90% of everything's crap. And one of the things that I found and we're seeing in various industries is good enough for a lot of people. Oftentimes disappointingly so. Um, I know if you've been on social media, you've seen way too many of these AI generated photos like I use. Like, this is good enough. There's been some various controversies here and there. I think Canada Air just got sued um, for using an LLM because their chatbot made certain promises about the refund process and they were being held to it, right? So I think there's going to be some companies that find out that maybe they need a higher standard. But when it comes to, say, quickly summarizing something, ChatGPT is good enough. Or another example that I use ChatGPT for, pull it back up, is it's really good at helping me find things based on really limited descriptions. Trying to see if there's one I can find. My mom has a tendency to look for like really give me just vague descriptions of songs. But for example, one that came up recently was I was trying to think of an example with algorithms, and so I said something like, "What is the uh, programming parable about sending messages back and forth, but never being able to confirm receipt? It relates to war."
By the way, this is the Byzantine general's problem. We'll see if it.
See, I don't need to pay for ChatGPT. I can just text Kevin, right? All right, so we'll give it a couple seconds, and then we'll go ahead and try to reload it and see if it. Here we go. The two generals problem, right? So for things like this, where you have a way to validate the output quickly and effectively, this tooling is amazing. It doesn't matter if it's hallucinating, as people call it. It doesn't matter if it's making mistakes, because common things I use it for is I'll paste in an entire article and say, summarize this. Or I'm going to be going to SQL Bits, and they have a very, very long thing about the conference and speaking. And I was like, hey, just give me some bullet points about any gotchas or anything I need to know about. And I found out that way that they were doing a whole day where they had 100-minute sessions, right? So anything where either there's an extremely large corpus of text to work off of, or you can easily validate the output, it doesn't matter if it's confidently wrong about a lot of stuff. But another issue is that its capabilities are wildly uneven, right? So for things like summarizing or writing certain types of prose, it's amazing. But for things like writing DAX code for Power BI, it is really, really bad. It'll make something that's plausible sounding, but it does best whenever there's a large corpus of text and a high quality corpus of text to work off of. And for niche programming languages, that just doesn't exist. And so if you can afford it, I highly recommend paying for ChatGPT and playing around with it so that you can understand what it can do. If you can't afford it, there's I think through Microsoft Bing you can access the latest version. You can access 3.5 for free. I think Microsoft just released the Copilot app, so there's ways that you can play around with it and still get a feel for it. The thing to understand, though, is anything you put in can be used as training data. So unless you're doing it through Azure OpenAI or you're paying for an enterprise license, do not put in anything that's particularly confidential, right? Someone at Samsung got in trouble for that. And then finally, change is coming. right? Like I said, there's plenty of industries that are already facing a reckoning because, especially like in things like marketing, where good enough is often good enough, or you have companies that see certain things as just pure cost centers, and so if they can outsource for pennies on the dollar to a drunken robot intern, they're more than happy to do that. There's plenty of tasks in my own life, right? Kevin does not want me texting him and then having to pay him $1 every time I need to know some sort of algorithm name. And so I'm more than happy to outsource that to ChatGPT. Another example is the vision capabilities. Let me pull that up. Let me see if I can find it. Oh, here we go. This is going to sound really dumb, but sometimes just to test it or just to save myself time, let's say I'm on TikTok, ignore the 11% on my battery, I'm a bad person. I took a screenshot of a TikTok and then I said, explain this. And it was able to read the text and explain the reference and saved me, minutes of Googling if I tried to do that. I'd even been able to do that for a foreign language. There's a foreign language meme where it was in Russian. Now, it didn't do a perfect job. A native speaker said, no, that's not quite right. But still, it's pretty impressive, some of the stuff that it can do. So the future is coming whether you like it or not. You might as well understand what it's good at and what it's bad at. So what math is involved? There's a couple different pieces. We're not going to get into a lot of the deep sort of stuff, but one of the most important ones is just understanding conditional probability, right? If X happens, what are the chances of Y? If it's raining, what are the chances I'm going to get wet? If it's not raining, what are the chances? There's a lot of linear algebra and matrix math involved. And there's a good amount of calculus involved, specifically around derivatives when we get around to talking about like gradient descent or that sort of thing. And so if you want to understand how this stuff works at a high level, then you don't need to know too much of this stuff. One of the references that I'll talk about at the end is Andrei Karpathy. He used to work at, I don't know if he's currently at OpenAI, but he's worked at OpenAI. He's worked at head of AI for Tesla. He's worked at a number of places, and he has some really great and helpful intro videos. So you don't have to necessarily understand how to do matrix math or how to do derivatives, although you do need to understand what a derivative is. So how should we be thinking about ChatGPT? I already talked about ChatGPT as a really fancy autocomplete. And again, if anyone has any questions, please feel free to interrupt and Kevin will raise them. So what do I mean by a fancy autocomplete? So I don't have a live audience, so it's hard to ask, but has anyone here ever played the autocomplete game? And if you don't know what the autocomplete game is, it's when you start the beginning of a sentence on your phone, and autocomplete gives you three options here, right? So what it's saying is if you start with "I really like," it thinks that it's either going to be it, the, or that, right? So essentially, it's implying that there's a 33% chance of any of them. In reality, it's probably saying that the middle one is more likely, and there's a bunch of other options it's not showing, right? And this is supposed to be a fun, silly game because you just see what your autocomplete says, and a lot of times it's refined based on the text that you use all the time, so it's more likely to suggest things that you're likely to say. So you can get some really silly outcomes. So the question is, what does it think that it's going to provide next? And the thing is, sometimes it doesn't actually work out in a particularly funny or interesting sort of way. So what it's done here is it really is just going off of raw probabilities, and we can see you can see that the text is extremely repetitive. It gets in these loops, right? And the reason for that, pardon me, the reason for that is that it's going off of the most highly likely outcome. It's not varying that because I'm just pressing the center button every single time. When it comes to large language models, this is called a parameter called temperature. I don't know off the top of my head why they call it that. I believe it relates to some sort of analogy or algorithm. But the idea is it's a knob you can tweak to say, oh, okay, how often do we want to pick something that isn't the most likely word or letter or whatever we're dealing with? Here we're dealing with words. And this relates to an idea called Markov chains. So a Markov chain is the idea where you simply just track the probability of a certain word following another one. And again, we can see based on the corpus that it was trained on and the fact that it always picks the most probable, we don't get anything super interesting. So what if we wanted to build something from scratch? Well, something we might do is called a bigram model. So let's say that my entire corpus is the phrase tomato, potato, and I give it the letter T. How do I know what it should output next? So bigram means by, to, and then gram letter. And so we can see here the first table is based on our corpus, which is very small. So our body of text is 2 words. 3 times we've seen the letter O after the letter T, and then once we've seen the letter A after the letter T. All of the other letters have shown up never. And so whenever we convert that to raw probabilities, what that tells us is that there's a 75% chance that the next letter is O and a 25% chance that the next letter is A. And so you could build a statistical model that produces these numbers based on whatever corpus that you want. And you could write some code to predict the next letters. And in Andre's videos, that's one of the things that he does. And this works up to a certain point, but there's a problem. So from that video, here he's showing every single combination of 2 letters. And you don't need to care exactly about what it's showing on there, but the key part is the darker ones are the more probable ones, right? And below are the number of times that it shows up. And so going back to our example, O and A would be dark, dark blue, and the other ones would be white. And you're able to use matrix math to take this probability matrix and apply it to predict whatever the next letter would be, right? The problem is that this gets really, really big depending on what the size of your token is. In the case of just a simple alphabet, it's a 26 by 26 matrix, or bigger if you include punctuation, or in his case, he includes start and end characters, right? So let me see if I can, what that means is a lot of times in a corpus, what you would also do is you would have a start token and you would have an end token. And the idea being that in our tiny little corpus, if it's the 2 words together, then it's always going to start with the letter T. Or if it's 2 separate words, it's always going to 50% start with T, 50% start with the letter E, right? But the key part is that this gets huge. And so we'll talk about it, but you have to figure out a way of getting around that. Now, for OpenAI, they use something called tokens. And a token can be anything that you want, but they have a very particular token list. And for them, it's about 4 characters of English text. And so you can see here, and we'll go pull it up as a demo as well, that I typed in, hello, it's nice to present to all of you, and then I typed in gibberish. And it's important because some of the tokens can be quite long. Here, space present is 8 characters, but it's 1 token, right? It's being mapped to a single neuron. Well, for a large language model, it's a bunch of neurons, but it's being mapped to a single numerical input. It's being mapped as token 1, 2, 3, 4, 5, or something like that. And for the gibberish, you can see that the tokens are much smaller, right? They tend to be 2 or 3 letters because it doesn't map to one of the longer ones that they've made. For non-English text, I have this as longer. It uses more tokens for non-English text, right? So the token size is very small. So if you're doing in French, for example, it could easily take twice as many tokens. For Chinese, it could be like 4 times as many tokens per character, 4 or 8, I think. And the important thing is each token corresponds to a unit of computation, right? So if we're going back, when we are trying to predict the next letter here, right? What comes after the letter T? Our token size is 1 letter. And when you use OpenAI and their APIs, you're being charged per token. And so what that means in practice is that for the same length of text, if your text is in French or Chinese or some language that doesn't tokenize as efficiently based on their tokens, you're paying twice as much for the same operation. So it's just something to be aware of, but the tokens here are completely arbitrary. So let's go ahead and pull that up just to show. So again, I can type in whatever I want. So I can type in Merry Christmas. And we can see that Christmas is an entire token. And we can see that it maps to specific numbers. Now in this case, it's a very large number. I guess exclamation is I'm not sure. Looks like exclamation might be 0. There's probably somewhere that we could see a list. There's a package for being able to tokenize the text so that you can send it to the API and all that kind of stuff, or see how much space it's gonna take up. But this is a really important thing to understand, is when we're dealing with large language models, it would be extremely inefficient to do a bigram kind of model or do a single letter kind of model, because essentially we have to run all of the math through the neural network 1 token at a time. And so the bigger the tokens we can use, the more efficient we can be. Another thing to think about is that large language models are essentially compression algorithms. And that's how we get around the issue that we had before, where if we are trying to map every probability of 26 to 26 different 26 different letters, then that ends up being 676 possibilities. We saw with the tokenizer, we're looking at 10,000. So that ends up being what, 100 million? Ends up being 100 million. It's too large to manage efficiently. And so the way that you deal with that is you find a way to compress it. And neural networks are essentially very effective compression algorithms. So the way that they work is in a neural network, we have a couple of different things. So if you're not familiar with it, the simplest kind of neural network takes in a certain input, right? So the idea would be that in our example, we see the letter T, and these other inputs would map to other things. So we might have the letter O and the letter A and what have you. And what's going to happen is each output is a possible token. And so instead of having every single possibility times every single possibility, we have a set of inputs for each possible token and a set of outputs for each possible token, and then a bunch of neurons connecting everything. A neuron is going to have a weight. It's going to have a I might need Kevin to help me with this, but there's going to be a weight inside and a bias inside for the actual neuron itself, right? And so what happens is, let's say that we see the letter T. So we're sending it the number 1. And what it's going to do is it's going to multiply that by a certain weight and add a certain bias, which affects how often it activates, essentially. And then there's a linear function that tamps it back down to be within a range of -1 to 1, right? And so sometimes that people use like the tan H function. Some people use like the logistic function. There's a number of different functions for that kind of stuff. But let's say that it ends up outputting 1. So 1 will come out here and then it gets multiplied by whatever our weight. So our weight might be 0.5. And so then what this hidden node sees is 0.5. And that continues onward until eventually it says, okay, I think there's a 75% chance that it's A and a 25% chance that it's O. I got those backwards technically, but you get the idea. And so part of what a large language model is doing is taking just gigabytes and gigabytes of, or petabytes even, of training data and compressing it down into whatever the model size is. Let me see if I still have LM Studio here. So I do. So in fact, you can run some of these free models locally. And so here, this Mistral model that I have is 4 gigabytes. And so what a lot of these models are doing is taking a lot of training information and compressing them very, very small. One of the other things is the idea of gradient descent. So we need a way, once we've randomly initialized our neural network and we're starting to show it data, we need a way to train it. So the way that I like to think about this is it's a game of Marco Polo, essentially. So if we, let me see if I can clear this out a little bit. Well, let me erase. Hold on. Erase all ink on slide. So the way that a neural network is trained is, let's say that we gave it the letter T and it said, oh, this should have been the letter M, which makes no sense, right? Maybe because it was randomly initialized or something like that. Well, what we have to do is we have to figure out, how do we backpropagate that information to say, no, this was wrong. What we really want is we want an O, right? Because what you do is you go through all the corpus of the text. You say, hey, what do you think it's going to be next? And then you adjust based on that. So we want to say, okay, we want to encourage it to say O, and we want to make it less likely that it says M. And the way that you do that is something called gradient descent. And this starts to get outside of the kind of the scope here. But the whole idea is you have to figure out, okay, it gave, let's say it ended up giving me a 1 here, a really strong signal. Well, do I want to change the weight here, or the one here, or the one here, or the one here, right? Which of these makes the most sense to turn the little dials on? And so with gradient descent, here's an example of a two-dimensional kind of thing where it's like you can either go left and right, or you can go front and back, and you move a little bit and then you adjust, and then you move a little bit and then you adjust, and you move a little and adjust, and you're trying to get closer and closer to the right configuration. But the thing is, and it kind of it mentions it down here, your neural network might have 13,000 different dials instead of just two. And so I compared to Marco Polo because you're kind of blind, right? If you ever played the pool game Marco Polo, you're taking a dive, and you pop up and you say Marco and you hear Polo, and you go in one direction or another. That's the way that gradient descent works, is basically at any given point, the algorithm moves a little bit and then it chooses which of these different, it says Marco, and it may be that this is the most effective one to tweak. And these other ones are not so effective. And the way that we determine that is calculus. This is where the calculus kind of piece comes in, because in the physical example, we're looking at the gradient, we're looking at the derivative, we're looking at the steepness of the curve. In a game of Marco Polo, you're looking at how loud the other people are, so to speak. And it may be that if we want to get this set to 0, the most efficient thing is we only have to tweak this weight by, let's say, negative 0.2. Whereas all the other ones, maybe we'd have to tweak it by like 3 or 4 or whatever, right? So it's all about updating things as efficiently as possible and getting all those changes all the way back to the very beginning.
Hey, Eugene, while you're on
Uh,
the topic, there is a
yeah,
question here. And when we're
please.
talking gradient descent, is the choice of going down really localized to a point rather than looking big picture?
Oh, that's interesting. So when we're talking about gradient descent, is the choice of going down localized to a point then rather than big picture? Um, so it it is. So the way that it works, it it's kind of complicated, right? So the way that it works is whenever there's a couple different layers of training that happens, right? So the very first layer is just simple prediction. And so literally, you might give the model these 5 words, and then you're going to ask it, okay, what's the probabilities of all the different possible outputs, just like we did with this. And you're literally just looking at this kind of level, just the next word, and then you're back propagating that. In practice, generally it's not done one by one. It's done using something called mini batches because they found that to be more effective. And so what that is you might do this 30 times and average together all of the tweaks that you need to make and then push those all kind of upstream. Um, but yeah, it's generally at the base level, it's looking at one word at a time. Now, when it gets to large language models in particular, there's something called attention or self-attention. This starts to get outside of my understanding of some of the math and all that kind of stuff, but that does allow it to kind of look at the text as a whole. Because the thing to understand is it's looking at the entire context window, right? So in let me clear this out. Da, da, da. So in our bigram example, what we were doing is we were giving it one token and saying, give me the next one. When you're dealing with a large language model, it is looking at all of the tokens effectively in order. The way that it does that is a little bit hard to explain, but for explanation purposes, just assume that it's providing it all in order. And it's going to key off of certain things. So for example, let's say, for example, that I'm writing for my Apple. Oh, it's actually predicting. That's funny. It actually shows us. Hold on. For my Apple. So you can actually see what it's. Actually, I don't know if that's OpenAI or that's probably just my browser. But for my Apple, I bought a. And the question is, what should it think that it should return? Now, the thing is, if it sees the word phone, it's going to put a lot more weight on that through this attention process, it's called. And it's going to be more likely to say a phone, like a case or something like that, because the word Apple is ambiguous. So hopefully that kind of helps explain. In practice, a large language model is looking at the entire context window, so everything before. So whenever you're using ChatGPT, it'll look at the last, I think, 32,000 tokens, somewhere around there. And because of something called attention, which was a very recent development, actually. Let me see if I can find it real quick. There's a paper, came out in 2017, I want to say, called Attention is All You Need. And the Andre's videos about some of this stuff is really, really good. I don't expect you to be reading this, but this is the concept that allowed generative process transformers, whatever it expands to become a thing. So for a while, it was a lot more simplistic. But hopefully that answers your question, and if it doesn't, I'm sure Kevin will bring it back up. But that is a great question. Let's see. In addition to the kind of token prediction piece, when it comes to training something like ChatGPT, there's a couple other sort of things that happen. So one is that first pass where it's just, okay, we're feeding in Wikipedia, we're feeding in Reddit, we're just predicting the next token. But as you can imagine, that's not really particularly great to interact with, because it's kind of like that autocomplete kind of game. It's not a chat assistant. So then what they do is they have humans write a bunch of ideal responses. Once it's been pre-trained, they have humans write a bunch of ideal responses to questions, and then they train it on that. And that's how you get this kind of assistant kind of personality to it. And so the pre-training, the first part, is very expensive. We're talking like hundreds of millions of dollars. But that next level of training is much closer to, say, millions of dollars or something like that. But that's kind of a lot of the big stuff that I wanted to cover. Again, in terms of demos, let me kind of show you what I was hoping to do, and then there's some other stuff I can cover, and then there's some links and references I have for everyone. So the demo that I was hoping to get set up, but I'm struggling with. Let me find it. Hold on one second. Oh, that's right. So Andre Karpathy has he's a couple projects, but the one that I wanted to do on Microsoft Docs and everything is Nano GPT. So he has some really, really good videos, and one of them he shows you how to build your own GPT. And what he does it on is some all of Shakespeare, basically. And he shows you how to modify it so that you using PyTorch to be able to predict these kinds of samples. Um, again, the demo gods were not with me, and it's telling me that Windows is not supported yet for torch.compile. So I don't know if I need to install Linux or if I need to get that sorted out. But if you on GitHub, he's got that. He's got micrograd, which is he's got a video where he goes through and kind of writes the logic for gradient descent from scratch, which is really, really cool to watch. So do Carpathy. So if we go to most played, his talk on intro to large language models is a must watch. It explains a lot of this stuff. His how to build ChatGPT is really, really great. And then his Make More series goes through starting at that whole bigram kind of approach. So I cannot be any more emphatic about I recommend watching these videos, checking this stuff out. Another resource that I recommend is 3 Blue, 1 Brown. I think it's machine learning. He has a lot of great videos about math in general, but he has a series on neural networks. And so he covers how they work in general. He talks about gradient descent and how some of that stuff sort of works. And then the one other main one is Wolfram. Stephen Wolfram has an amazing blog post about really a lot of the deep dive about ChatGPT and how this stuff works, right? And so he talks about, okay, here's how we're just predicting the next word, and things like trying to use temperature to say, okay, we don't want to always take the most common word. We want to sometimes pick other ones, but it's a very long, but actually enjoyable read for a lot of this stuff. But like I said, in general, a lot of what I've been doing is just trying the tooling using ChatGPT. You can use it for free with Bing to understand what it can do. What I'd like to do oh, sorry, I apologize for being all over the place. There's a book as well. It's O'Reilly books now. This is a machine learning book in general, and I also found it extremely helpful. Oh, it doesn't. It's mad because it's an ad. Hold on. Oh, come on. I have a network level ad blocker. I don't remember the name off the top of my head, so I want to get it right. History. Generative deep learning, second edition. I looked a little bit at natural language processing. That was a little bit hard for me to get into, but this book is amazing because what it does is it starts at very simple generative modeling, and some of the analogies are a little bit goofy, but they do help sometimes. But then the author goes through different types of generative modeling. So one of the ones that he talks about is GANs, or general adversarial networks, where you make one neural network to make stuff, and then you make another neural network to try and detect that stuff. And they just kind of fight with each other, making higher and higher quality stuff. but it talks about diffusion models, which are what used for stable diffusion, and I don't think it's used for Dolly anymore. But then eventually it gets into transformers, right? And it talks about attention, and it talks about, here we can see the tokenization process. It talks about just all of the complexity here with the attention heads and the matrix math and all that kind of stuff. So, recapping, I highly recommend Andre Karpathy's stuff. I highly recommend 3 Blue 1 Brown. Stephen Wolfram has a very long but very good blog post. What is ChatGPT doing and why does it work? And then Generative Deep Learning second edition be prepared to read it 2 or 3 times. There are definitely times where I read through a chapter and I'm like, I didn't understand any of that math, and I had to kind of go back and reread it. But it is approachable in the sense that you can see how you get from A to B, right? So, like, as an example, it has demos that you can do, but it shows how you can encode pictures of clothing on a 2-dimensional kind of plane, and how you could use that to generate new types of clothing based on where you're at, right? It had stuff on how they're called convolutional networks. Let me see if I can find it. But it helped me understand how a lot of the image generation kind of stuff works. So I recommend all those resources. We've got another 10 minutes. Does anyone have any questions?
Yeah, there was a question from chat that I'm not going to be able to help you on.
Oh, no.
From your reading of Wolfram, did he discuss any intuitions for what gradient descent looks like in high dimensional space versus 2D or 3D space?
No, he did not talk about that at all. I don't even know if he mentioned it at all. The Yeah, he only talked about it at a high level. One the book, however, I think does probably touch on that a little bit. Specifically, what I'm thinking about is, does it touch on micro batching? I feel like the book touches on it a little bit more. Another, I almost forgot about this. Hold on. There's a newsletter I also recommend, and a guide worth following. I think his name's Ethan Mollick. So give me a second. Ethan Mollick. One useful thing, Substack. Ethan. If you want to keep up on this stuff, he's a researcher in this area, and he talks about some of these things. And I think I follow him on Twitter, and I think I found some research articles through him. The reason I bring all this up is the big thing with highly dimensional versus 2 or 3 is if you're careful, you're way less likely to hit a local minimum. Whereas, as you can imagine, in 1 dimension, it's really easy to get stuck in a valley. In 2 dimensions, it's still pretty easy. But there's some research out there suggesting that in this highly dimensional kind of space, that there's a lot of room for improvement. Let me see if I can find him on Twitter. No, Ethan Mollick. Here we go. So he's Mollick on Twitter. I don't know if he's posting anywhere else, but he's often posting a lot of research articles and that kind of stuff. And here we go. So, like, there's a lot of stuff coming out like this where there's just evidence that if you just throw more, I guess this one's more about context length, but there's evidence that more data and more compute, you keep having returns on that investment. So the short answer is no. Wolfram's blog post did not get into that at all. If you care more about the really nitty gritty, check out the book. Check out Ethan Mollick and subscribe to his newsletter. It's completely free. And there's, from what I've seen just tangentially, so I don't remember off the top of my head like a research article, there's evidence that essentially when you're playing this game of Marco Polo with gradient descent, you have so many more directions you can go in, that it's easier to avoid getting stuck in a local minima. One other thing related to that is part of why I recommend watching Andre Karpathy's stuff with like building a GPT from scratch is a lot of this stuff is witchcraft. And what I mean by that is we do things, we set certain parameters like the temperature or the micro batching or the way that we pre-initialize that neural network and set the starting values randomly. And we don't know why it works. We just know from experience that it tends to work better. And so that's kind of the current state of things, is there's a lot of best practices where we just know it works, but we don't know necessarily why. One other related to that, Bloomberg GPT. There's a great video called Bloomberg GPT where they talk about how they built their own chat GPT based on proprietary data of theirs. And he goes into a lot of the challenges there. And again, a lot of this stuff is just, hey, we know this works. And they in particular ran into, okay, we kept hitting these plateaus at various points. So, Kevin, would it be helpful if I posted some of these links in the chat or no?
I've been posting links as
Awesome.
we go
You're the
along.
best. Thank you. But yeah, hopefully that answers your question. Any other questions?
Well, if there are any other questions, get them in chat.
Mm-hmm.
Not a whole lot
Otherwise,
right
I
now.
can.
I've been helping out a
Oh,
little bit, but
yeah. One other thing, if you want Chat GPT at home, check out LM Studio. It's free. I don't know if it's open source or not, but you can load down a bunch of models from Hugging Face. Let me see if I can get this one running. So I have to load that up. I want to do a new chat. So I think I have to reload the model, which can take a little while. So this is going to be pretty awful because I'm running a very small model, relatively speaking. But I can say, write me a poem. And it's going to be just butt slow, right? But it actually works. And again, it's going to be really bad at some of these tasks, right? So if I tell it, new chat, write 10 sentences ending in the word apple, it's probably going to fail every single one of them. Oh, we got one. Yeah, that one didn't work. But if you want a way to play around with this stuff and to make sure that OpenAI is not training on your deepest, darkest secrets, I recommend LM Studio. It's really easy to get set up, but it can be resource intensive depending on the size of the model that you're doing. As you can see here, this Mistral Instruct, the version I'm running, which I forget what the quantized the Q4 stands for, but it's a compressed model. It's not as detailed and accurate, so it's not as good. But we can see here 1, 2, 3. So it only got a 3 out of 10 on the Apple test, but really, really fun little tool to be able to play around with this stuff.
by the way, I'm going to call out the bloke up there. Fantastic resource on Hugging Face, Tom Jobbins. He puts
Oh,
together
nice.
a whole bunch of optimized and minimized models. So it'd be 30-something billion parameter model that normally would require, say, 24 gigs of VRAM on your GPU, and
Right.
different you'll have different variants. It'll be like, oh, this one's 7 gigs, this one's 11 gigs. So if you have a regular card, you'll have better luck with
Exactly.
it.
Yeah. All right. Cool. I think that's probably it, unless anyone has any final questions. I guess I should say this is not my specialty. My specialty is Power BI, but you can reach me at eugene@sqlgene.com. I spelled that wrong. I'm on LinkedIn at Eugene Meidinger, and I'm on Twitter at SQLgene. All right, cool. So I will stop sharing.
Thank you, Eugene. That was a great presentation. By the way, I do want to make mention that Eugene has graciously allowed us to post the video on YouTube, so it will go up there in case you need to go back and watch it again, grab some links afterwards.
Perfect.
All right, with that, we are going to wrap up for tonight. Hope you all enjoyed it in chat. Got several thank yous. I think you did a great job. And we are going to wind things down. We are ending the month for TriPass. Our next presentation will be on the 12th, and we'll have those posted at meetup.com/TriPass. 3 more coming up in March, so hope to see you then. And until we do see each other in a future presentation, everyone, take care.